Okay, so we're now going to look at 2.8, and we're going to begin with question number 2. So we're going to read it, we're going to figure out how to set it up, and then we're going to solve it. A woman has $1.70 in nickels and dimes. She has 5 more dimes than she has nickels. How many nickels does she have? So let's think about what we've got. Okay, we've got 2 types of coins. And each of these coins have a denomination. So we've got coins. So this is going to be the number of coins. This is the denomination. So we've got nickels. And we've got dimes. And the nickels are going to be worth 5 cents. So that's 0.05. Dimes are going to be worth 10 cents. So that's 0.1. So let's now figure out how many we have in each one. So when we read it, it says we have $1.70. Now that's going to be my total amount. So we'll deal with that in a moment. She has nickels and dimes, so I labeled them as 5 cents and 10 cents. And it says she has 5 more dimes than nickels. So 5 more dimes than nickels. So we do not know how many nickels we have. So I'm going to call the nickels the variable x. And what do we know about the number of dimes? Well, it says there are 5 more dimes than nickels. So the dimes is going to be then x plus what? X plus 5, right? Is everyone okay with how I got to that step? So we've got nickels and dimes. We've got our denominations here, 5 cents and 10 cents. We don't know how many nickels that we have, but we do know that we have 5 more dimes. And now remember, if I add these across, I get that 2x plus 5 here. And this is the total coins, not the value of the coins, total number of coins. Okay? Not the value of the coins. You might have, 10 dimes, and that's worth $1. The dollar is the value, the 10 dimes, the 10 is the number of coins. So now we're at this step. So now we're going to look at the value of each one. And your value is going to be the denomination times the number of coins. Okay, because these are all pretty much the same. Whether it's pure, whether it is a distance problem, or whether it's an interest problem. Okay, so all these are pretty much the same. They're going to be these 2 multiplied together. So let's look at our nickels. Okay, the nickels are worth 5 cents apiece. So that's 0.05x. And then we're going to add to that the number of dimes. And dimes are worth 10 cents, so that's 0.1. And how many dimes do we have? Going back up here, we've got x plus 5. And what's my total value of all the coins put together? Well, if we look at our question, the total value of all the coins put together is going to be $1.70. So there's your equation. All you need to do is finish it, and that's going to give you the number of nickels that you have, and that's going to be your answer. I'm not going to finish it for you. You should be able to finish it yourself. But here is your equation. So is everyone okay with how I set it up? We've got coins, and we've got the denomination of the coins. So they're either nickels or they're dimes. Nickels are worth 5 cents. Dimes are worth 10 cents. We don't know how many nickels that we have, But we do know there's 5 more dimes than nickels. And then we just add them across. We don't really work with this, but I put it here just so you don't put the $1.70 there, because that would mess you up a bit, so we don't want to do that. So we add those across. It gives me total number of coins. Then we build our equation based upon the value of the coins, which is the coins times their denomination. And you'll finish that out. That's going to then give you the number of nickels, and that is what you want for your answer there. Okay? And that was question number 2. Question number 4. Very similar again, but what we're trying to do in this case is we're trying to make a coffee blend. So we've got different coffees that cost different amounts of money, and we want to blend these together to get a mixture of coffee that we can sell for a specific price. So a merchant has coffee that's worth $30 a pound, and she wishes to mix with 30 pounds of coffee that's worth $80 a pound. And she wants to blend these together so that she can get a mixture that sells for $40 a pound. How many pounds of the $30 coffee should be used? So let's see what we've got here. We've got 2 types of coffee. We've got the number of pounds of that coffee, and then we've got the price of that coffee. So when we read it, it says a merchant has coffee worth $30 a pound. So that first one here, it's going to be the $30 coffee. So its price is going to be $30. And then she's going to mix that with 30 pounds of coffee. So number of pounds over here for the second one is 30. And the second coffee costs $80 a pound. We don't know how many pounds of the $30 coffee that we need, so I'm going to use the variable x. And we're going to add these together. They always add together to give us our third one, which is then x plus our 30. And we want this mixture of coffee to cost $40 a pound. So we're making a coffee blend. Some coffees are worth more than others. We want to get maybe a nice blend for a specific taste or maybe a specific price. But we want to cut some of that more expensive coffee with a lower grade coffee and get a mixture that we can then sell. So we've got $30 coffee a pound, unknown number of pounds in that container. We've got coffee that's $80 a pound. We've got 30 pounds of it. We want to mix them together to get a mixture that we can put on sale for $40 a pound. Now we need to build our equation. And we're just going to look at this in terms of the total cost. Okay, so we'll call this the cost. Now you can label these whatever you want, just as long as you keep track of these get multiplied together. So we're going to go ahead and put our cost here, and that's going to be the number of pounds in each coffee times the price. So cost is going to be the number of pounds times the price. So looking at the left-hand side, the first one, we've got $30 per pound for that coffee. Unknown number of pounds, x. So that's going to give you 30x. The second type of coffee, we've got 30 pounds of that coffee, and that coffee costs us $80 a pound. And then 1 plus 2 is 3. So on the right-hand side, we put these together, and we get 40 times x plus 30. So now we have our equation, and you can now solve this equation and find the number of pounds that we have of that $30 coffee. I don't want to work all these out because it would just take too long, and I know where we struggle at more than any other place is the setup. Most of you should not have any trouble solving this equation. You solve it for x. X is going to be what you want. The more of these that we can set up, the more they'll start to make sense. But they're all very, very similar to each other. So question 5. Okay, question 5 is an investment problem. Up here, we'll go through question 5. So Marty received an inheritance of $60,000. So she invested part at 4% and the rest at tax-free bonds paying 6%. Her income was $2,600. Find the amount invested at the 4%. So let's think about what we've got. We're going to invest money. Now, when we invest money, we have 3 things that we get out of that on our statements from the bank. How much money we put in that account or that fund, the percentage rate that fund is paying out, and how much money we got out of the fund. So how much is in there, total value of the total fund, what percentage it pays out, and how much interest or money we made for profit. So these are going to be amount, so that's how much is in that account, and percentage rate that it pays out. Remember, this over here is the total amount. So when I read this problem, the first part that I encounter is that $60,000. So what does that $60,000 represent? Well, that represents not the interest, right? That represents how much money I've got in my accounts. If I were to cash those accounts out, the total amount of all those accounts put together would be your $60,000. So that's going to go over here in 3, because that's your total. Not the $2,600, because the $2,600 is the interest. And you've got to differentiate between the interest and the total value of the accounts. Now, what do we have? We've got 2 different funds here. One pays 4, and one pays 6. Now, what do we know? Do we know how much is in either one of these funds? No, we don't. We do, however, have a total. So, if we don't know either one, what do? Well, we call the first one X. Remember that? Okay, so the first one's going to be X. And what about the second one? Remember the second one, we don't know what it is, but that's going to be your total minus X, right? You don't know either one, you call the first one X. And the second one is our total minus X. And what's our total? $60,000. So that's going to be 60,000 minus X. Do you see how I'm putting the pieces in there? The only way we can get good at these is just to do a lot of them. And you'll see them again in intermediate, and you'll see them again in college algebra. So our goal is, by the time you see this in college algebra, it's not going to be difficult at all. You'll know exactly how to approach this type of problem. Now, what do we look at next? We look at our interest. And how do we find the interest? Well, the interest is going to be the amount times the percentage rate. The amount times the rate is going to give me the interest. So our first one, now make sure you write the percentages as a decimal. So our first one is going to be 0.04. for the interest rate times x. The second one is going to be 0.06 times your 60,000 minus x. And then the third one is the total interest or income. And we made a total of $2,600. So now you should be able to finish this one out. So distribute through, combine like terms. You should then be able to solve that particular problem. I know the setup is where we struggle, so we're spending a lot of time talking about the setup. Question 7. This one's a little bit different. But we're going to now look at question 7. At the end of the day, a storekeeper had $1,600 in the cash register. That's counting both the sale of the goods and the sales tax of 5%. We want to find the tax. Let's talk for a moment about how taxes work. If I go to the store and I buy, let's say, a $1,000 TV, do I really pay $1,000? No. I pay a little bit more. Let's say our tax rate's 9%. Okay, so if I go to the store and I have $1,000 for that TV, I pay more than $1,000 because if our tax rate is 9%, then you would take your $1,000 that you paid, right? That's the price. You would multiply that by 9%, which is 0.09. That is $90. So $90 in tax. And then I add that back to the $1,000, and I end up paying $1,090 total. So does everyone understand how taxes work? If it was a $5 item, and let's say it was a 10% tax rate, I would pay $5.50, right? Because 10% of that $5 is 50 cents. Add them together, you get the $5.50. So how do I find the tax? To get the tax, I have to take that percentage rate times the amount that I have for the price of the item. So when we look at question 7, this one involves a total. So question 7, I've got $1,680 in the cash register. So this is going to be the sales plus the tax. That's going to equal $1,680, right? So that's what we've got. So we've got the sales of the items, tax, and that gives me that $1,680 total. Now, what we need to figure out and determine is the amount of the tax. What we don't know is the sales. So I'm going to call the sales X. So the sales is going to be the X here. Now, what about the tax? Well, the tax rate is 5%. So how do I find my tax that I'm charged? Well, the more money I spend, right, the higher the tax is, the higher the tax value is. So how do you find the taxes? Now your taxes are going to be 0.05 times X. Why is it times X? It's times X because X represents how much you spent. So that's the cost of the item. So if I spend $1,000 on a TV, I'm going to spend way more money than if I just went and bought a $5 meal. And a lot more in taxes, right? How do you find the taxes? You have to take the tax rate times the amount that you sold. That's going to then equal that $16.80. I'll go ahead and finish this one out, just so you can see how to get both parts. Be very, very careful when you add these together on the left-hand side, because this is 1. Okay, 1x here. So when we add these together, we get 1.05x. That equals 1680. We'll divide by our 1.05. That leaves me then with the value of x to be, okay, so we got 1680. We're going to divide that by 1.05, and that gives me x to be now 1,600. So that 1,600 represents the sales. So we took in $1,600 in sales. But that's not what I want. I want to find how much I've got to pay the government in taxes. So how do you find the taxes? Well, for the taxes, you're going to take that $1,600 that you spent. You're going to multiply it by the 5% tax rate. And that's going to give us that $80. Right? The 1,600 times your 5% gives you 80. And so you're going to have to pay $80 in taxes. So that's how it's done. And this is done all the time because, when you go purchase an item, what happens? You're charged a bill, right? And then that merchant then has to figure out how much do I send back to the government in taxes. So they have to keep track of how much the item cost, and then they have to do this, or a computer does, and it says write the check for the government, in this case for that $80. Okay? You spent $1,680. Items cost $1,600, so that's what the merchant gets. Government gets $80. We don't see that, but the computers all do that now. When you go buy an item at Walmart, Walmart knows how much they get to keep and how much has to go to the government in taxes. So that's question 7. 9 is next. So that 7 was a little bit different. 9 is also a little bit different. Now, what we're looking at on question 9 is we're looking at 2 people, and we're going to compare their ages. Derek is 4 times as old as Sarah. 2 years ago, the sum of their ages was 36. How old is each of them now? So let's talk about how they relate to each other right now. Right now, we've got 2 individuals. We have Derek and we have Sarah. So what do we know about Derek and Sarah? Well, if we read our question right here, Derek is 4 times as old as Sarah. We do not know Sarah's age, so I'm going to call Sarah X. And how does Sarah and Derek relate to each other? Well, Derek is quite a bit older, and he's 4 times older, so that's going to be 4x. Is everyone okay with that? Right? See how they relate to each other. Now we're looking at 2 years ago. So 2 years earlier. What would these be 2 years earlier? Well, 2 years ago, they're both 2 years younger. So Derek would be 4x minus 2, because he's 2 years younger, and Sarah would be X minus 2, right? Because they're just 2 years younger. And so that's how we have to make them relate. This is how old they are now, how they relate to each other right now. This is 2 years earlier. Now we know 2 years ago, they summed to be 36. So this is 2 years ago. So 2 years ago, these are going to sum to 36. So that means Derek 2 years ago would be 4x minus 2. And Sarah 2 years ago would be x minus 2. And how old were they 2 years ago added together? 36. You have to relate it back to the age 2 years ago. You can finish it. Now, when you finish it, what are you going to find? When you solve it for x, what does that give you? When we solve it for x, we get how old Sarah is today. X goes back with Sarah's age today. How old would Derek be today? Well, you take your answer and you multiply it by 4. So if Sarah came out to be 3, Derek would be 12, right? You multiply it by 4. We just had to do the 2 years earlier to build our equation here. Then you can solve that and plug it back in and get how old each of them are right now. Okay, because this is what we want is right now. We want this part. So that's what we want. We want to figure out the value of x. That's Sarah's age right now. Multiply it by 4, and you get Derek's age right now. We had to look at what they were 2 years earlier, so that's why we subtracted off 2. So that takes care of question 9. They're all a little bit different. Some of these are going to require a picture for us to work through and label. Some of these just require some creative thinking, like this one does. So we've got 3 more to look at, and then we'll take a short break, and we'll look at inequalities after that. So let's look now at question 13. And if anything confuses you, just be sure and say something. We've got plenty of time to go over each of these in more detail if we need to, because the next section is one of the easiest ones. This, I think, is one of the hardest ones. But 2.9 is one of the easiest. Helen invested $13,000. Let's kind of focus on what we're working on here. That way it makes sense. So let's try to focus on the math here. Helen invested $13,000 in an account that paid 3%. How much additional money must be invested in an account that pays 6% so that the average rate of return on investments is 4%? So let's see what we've got here. We're going to use dollars to represent the two accounts. And they're going to be added together to give us a total over here. So starting off, Helen's got $13,000, and she's going to put this in an account that pays 3%. Wait, wrong one. Let me look here. $13,000, yep, pays 3%. So our amount is going to be $13,000. Percentage rate that it pays is 3%. Is everyone okay with how I picked that piece up? Right? Got $13,000. Interest rate is 3%. Now, we want to add in some extra money. It says, how much additional money? So we don't know how much we're going to add in. So we're going to put the X there because that represents the additional money. We don't know how much it is. So we're going to represent that with X. And that goes in a different account. And this different account, it pays more. It pays 6%. Remember, we add these across to get our total. So adding across here, we get our 13,000 plus X. And then what percentage rate does it pay out? Well, we want it to pay out an average rate of return of 4%. So an investment broker might do this. He's going to invest some at 3%, some at 6%, because at 6 might be a little bit riskier. But we know our goal is to get 4% overall. So that's what he's going to do. He's going to put some of it here in a safer account, more of it in a 6%, kind of a riskier account, and then we get 4% overall. Build our equation from the interest, and your interest is the amount again times the rate. Part number 1, 3%, that's 0.03, $13,000 is our amount of money, right? These get multiplied together here. Second one, what do we have? 6%, so that's 0.06. How much is in there? Unknown amount, X. 1 plus 2 is 3. That's the way I remember it. So that's going to be the right-hand side. And 4% is 0.04. How much is in there? 13,000 plus X. So that's how we build our equation. So we've got two different investment funds. We put 13,000 here, 3% for the rate of return. We're going to put some money in a 6% account. It's a little bit riskier. We want to make sure that when we're done, we get 4% on the rate of return. So we've got to figure out how much extra money we put in. So we build our equation. We'll finish it, solve it for X. And X is going to represent the amount that goes into the 4% total. I picked question 15 because it's kind of a difficult one, and you're going to see the exact same question in college algebra and also in intermediate. So the next two classes, you're going to see the same pretty much question, just different numbers. It is necessary to have a 40% antifreeze solution in the radiator of a car. The radiator now has 60 liters of a 20% solution. How much of this should be drained and replaced with pure antifreeze to get the desired strength? So we're going to have to think about what this one is with an analogy. And the analogy I like to use is making sweet tea. So if I want to make sweet tea, and I make my tea, and I've got a gallon pitcher of tea, okay, so it's already made up, and I try to add in a couple of cups of sugar, what's going to happen? If it's full, it's going to overflow, right? So if you got the big container of tea, and you forgot to put the sugar in until the end, if I try to add the sugar in when it's full, it's going to overflow. So how would you solve this problem? Well, if I need to put in 2 cups of sugar, what am I going to do? Take out 2 cups of the tea first, right? Drain it out. And then once it drains down, then I can put the sugar back in and it'll be filled back to the top. So part of it's going to have to be drained out and then put back with the sugar. That's what's going to happen here. Normally in a car, you would just drain the radiator fluid and change it out. But if it's something more expensive like a truck, a diesel truck, it might be cheaper and more efficient just to get it back to the right strength instead of wasting all that fluid. In a car, though, normally we would just drain it all, start over. But if it's like a diesel truck, you don't really want to waste a whole bunch of antifreeze, so you're going to watch the percentages and get it to the correct strength. So what they've been doing is they've been adding water. And we're going into winter, so we want to make sure that we get the right concentration so that our engine doesn't freeze. When it says it is necessary, that goes in box 3, because box 3 is what we want at the end. So after we're done doing all the service, we want that 40%. So that's going to go over here. And we've got the amount that's in there, and we've got the percentage rate of antifreeze. So we want at the end this 40%, because this is box 3, and that's what we want. So we want to end up with 40% antifreeze. Okay, so that's what we got. Now, the truck comes in right now full. So the truck comes in full of antifreeze, and it comes in full, and it's 60 liters, and it registers at 20%. Now, when we're done, it still has to be full, so it's still going to be 60. Because it comes in at full, you're going to drain some of it out, and it better be full when it leaves, right? Because I can't just drain some of it out and fill it back up. I've got to drain it out and replace it with pure. So this is what I have right now. This is what I want. How are we going to accomplish making it stronger? We're going to accomplish making it stronger by adding in some pure. Pure antifreeze is 100%. Now, if I just add in X, that's not going to work, because that goes back to the tea example. If I've got the container of tea and I try to add sugar in, if it's full, it's going to overflow. Right? So what did we do? We drained part of it out. If I need to add 2 cups of sugar, I have to take out 2 cups of tea. Same concept here. If I'm going to add in some pure here, I have to take it out at the beginning. That preserves your equality. Whatever goes in has to come out. Because what happens here? 1x is negative, 1x is positive. If you add them across, what do? Cancel, and they leave you with 60, don't they? Right? So whatever goes in has to come out. That way it makes it the same. Because if I just add more antifreeze in, all it would do is overflow. So it's full. I've got to know how much to drain out and how much to put back in. Now we're going to work with our pure antifreeze. So let's look at the pure. Pure is the amount times the percentage rate as a decimal. So the first one is what we've got right now. And as of right now, we've got that 20%. We've got 60, but we're going to have to take some of it out. We're going to have to drain a little bit of it down. That way, when we drain it down, we can add in our pure. Now, 100% is 1. So that gives you then just 1x or just x. You can put the 1 there if you want, but it's understood that it's there. I'm going to go ahead and put the 1 in. So you see that this 1 goes with the 100%. Right? 100% is 1. Those go together to give me then this 40% solution. And how much do we have in there? 60 liters, because we can't overflow the radiator. So part of it goes in, part of it's taken out. It gives us the concentration that we want. Normally, again, for a car, you would just drain the whole thing out and start over. But if it's a semi-truck, they wouldn't do that because we're talking a lot more in terms of coolant. It's more expensive. So you would do something like this. Type the numbers in the computer and it would tell you what to do. But this is how it would do it. Okay, we're doing it by hand and we can figure out how much we need to take out and how much we have to put back. One more and then we'll take a short break. A bank teller has $5 bills and $20 bills. The teller has 5 more of the 20s. The total value of the money is $750. Find the number of $5 bills that the teller has. So again, we've got the number of bills, just like the coins, and then we've got the denomination. The number of bills and the denomination. So I'm working at this bank, and I've got two types of bills. I have $5 bills, and I've got $20 bills. And what do we know? Well, we don't know either one, but it says the teller has 5 more of the 20s. So we don't know how many $5 bills we have. So that's unknown, so that's going to be the X. But what do we know about the 20s? Well, we know there are more of them. And by reading the question, it says there are 5 more. So 5 more would then be X plus 5, right? 5 more of the 20s. When we add these across, what do we get? We get 2X plus 5. Now we're going to look at our value. And the value of the money is going to be the number of bills that we have times the denomination. So we've got bills and we've got the denomination. So let's see what we've got in the first one here. Okay, bills times the denomination. So that's going to be 5X. The second one, $20 bills. So that's your 20 here. And how many do we have? X plus 5. And how much are those total bills going to combine together to give you? Well, if I put all the bills together, then I get $750. Okay, so it's going to be worth $750 total. This is the total amount of money. So that's going to be your total amount of money there. You can now finish it. When you finish it, you're going to find X, and X represents $5 bills. So that's going to be your answer. So we've got bills and denomination. Same thing with the coins. Remember, we did a coin problem where it was coins and denomination. We then found the value of each stack of bills. We put them all together. They totaled up to give me $750. Now we can solve it out and we can figure out how many 5s and how many 20s we have. So now we're going to go ahead and take a short break, and let's meet back here at, how about 9:35? So that'll give you about a 15-minute break. So let's meet back here at 9:35.